All right, let's talk about something that sounds like straight up magic, a technology that lets us get answers from data without ever actually seeing the data itself. You're probably thinking, no way, that's impossible. Well, let's find out.
So, to get our heads around this, let's start with a classic puzzle. Picture three friends. Let's call them Alice, Bob, and Charlie. They're out to dinner, and they start wondering who makes the most money. But, it's awkward. Nobody wants to just blurt out their salary for everyone to hear.
So here is the million-dollar question. Can they figure out who has the highest salary without any single one of them revealing what they actually make? It sounds completely impossible, right? But here's the thing. There's a solution, and it's changing everything we thought we knew about data privacy. This puzzle, it's not just some fun little brain teaser you'd find in a magazine. It's actually a perfect illustration of a huge challenge in our digital world. Think about it. The salary problem is basically the same problem we face every day. How can we work together and learn from sensitive data when privacy rules, or just plain old competition, stop us from sharing it? So what is this incredible, almost magical solution? Well, it's got a name, and it's called Secure Multi-Party Computation. Let's dive in. Okay, that's a mouthful, so let's just break it down. Secure Multi-Party Computation, or MPC for short, is basically a cryptographic toolbox. It lets Alice, Bob, and Charlie do exactly what they wanted. They can run a calculation, in their case, find the maximum number, on their private inputs, their salaries, and get the final answer, all without anyone's individual salary ever being exposed. Now, any MPC system worth its salt is built on two promises, two ironclad guarantees. First, input privacy. Your secret stuff stays secret, period. The only thing anybody ever sees is the final combined answer. And second, correctness. You can be absolutely sure that the answer is right, and nobody messed with the calculation. So to really get this, cryptographers use this really cool analogy. Imagine an ideal world. In this world, our friends have a buddy named Tony, who is perfectly trustworthy, like incorruptible. They just whisper their salaries to Tony, he figures out the biggest number, and then he only announces the final result. Simple, right? But in the real world, there's no Tony. So what MPC does is it lets the friends, just by sending encrypted messages back and forth, get the exact same result as if they had a trusted Tony. It's like a virtual trusted person made entirely out of math. All right, so how on earth does this actually work? I know it sounds like some kind of wizardry, but it's really just incredibly clever mathematics. Let's take a little peek inside the black box. At a super high level, there are two main ways to do this. For just two people, they often use something called garbled circuits. It's kind of like one person builds a scrambled up logic puzzle that the other person can solve without ever seeing the original inputs. But for three or more people, like our friends at the dinner table, a different method is way more common. It's called secret sharing. And that phrase right there, secret sharing, that is the absolute key to the whole thing. Let's really look at what that means. Imagine Alice's salary isn't just a number, but it's a secret recipe. Now, she splits that recipe into three pieces. She keeps one piece for herself, gives one to Bob, and one to Charlie. Now, here's the crucial part. A single piece of the recipe is totally useless. It doesn't tell you anything. So Bob and Charlie do the same thing with their salary recipes. Now, everybody is holding one piece of every secret, but no one has a complete secret. Then, they start doing math on just the recipe pieces they're holding, and it's only when they bring their final computed pieces together at the end that the answer, the best dish, or in our case, the highest salary, reveals itself. The original recipes, the individual salaries, they're never ever put back together. Okay, so that's a pretty cool analogy, and the theory is fascinating, but is this just some academic idea? Nope, not at all. Let's look at how NPC is being used in the real world right now. And this didn't happen overnight. The journey has been a long one. It actually started as a theoretical idea way back in 1982. By 1987, researchers proved that pretty much any computation could be done securely. But it took all the way until 2008 for the first big real-world use case, a national auction for sugar beets in Denmark. How cool is that? And now, in the 2020s, you have major companies forming an alliance to push this tech into the mainstream. And this isn't just history. This stuff is making a real difference today. In Boston, a bunch of companies used MPC to analyze all their payroll data together to find gender and racial wage gaps. Think about that. No company had to share its sensitive salary info with its competitors, but they all got this super important insight. In another case, in Pennsylvania, different county departments were able to combine their private data to make better policies, all while keeping citizen information completely private. So you see, this technology is way more than just a clever trick. It represents a fundamental shift in how we think about data and collaboration. It really points to a whole new future for privacy. So why does all this matter? Well, because MPC unlocks the value of all this data that's currently just locked away in silos, totally unusable because of privacy rules or business rivalries. It lets competing companies work together for the common good. It lets hospitals train medical AI on patient data with ever exposing that data. It fundamentally puts control back where it belongs with the owner of the data. At the end of the day, it all comes down to this one simple but incredibly powerful idea. We can finally separate the insight from the raw data. This isn't just about data protection anymore, it's about data use without exposure. And that just leaves us with this one fascinating final thought. We've spent decades building a world designed to share more and more data faster and faster. But what if the real future of a secure, private digital world isn't about sharing data better, but about being able to get the answers we need without ever having to share it at all?